In this lesson, you will survey some languages that have been derived from XML. You will learn about Microsoft's Channel Definition Format or CDF language, which is used to develop web content channels for Internet Explorer 4. Additionally, you will get a glimpse into 3 other XML-based markup languages: the Synchronized Multimedia Integration Language or SMIL, the Mathematical Markup Language or MathML, and the Resource Description Framework or RDF. A recent trend in delivery of web content has been to put some kind of intelligence behind it. The most hyped form of intelligent content delivery is push technology. Some software makers have been quick to apply this term to their products in an effort to capitalize on the hype. But in many cases, the term is being misused. With the release of Internet Explorer 4, Microsoft became the first software maker to propose a coherent vision of intelligent content delivery. Microsoft's approach to handling managed web content, an activity that Microsoft calls webcasting, is comprised of a 3-tiered model. The 3 levels in the model include subscriptions, channels, push technology. Subscriptions. Subscriptions are essentially smart bookmarks. If you subscribe to a page, Internet Explorer will proactively check to see if that page has changed from the last time you looked at it. If it has changed, the browser notifies you and gives you the option to visit the modified page. Channels. Webcasting channels are structures that allow webmasters to group individual pages together into a single entity. Channels allow webmasters to manage the content that users see and to make users aware of scheduled updates to the content. Push technology. True push technology involves a server broadcasting to many receiving client programs. Microsoft's NetShow product is an example of a server that can do true push technology broadcasting. The NetShow server actively sends content out to users' desktops where the content is played on the NetShow player. Both the subscription and channel approaches rely heavily on the Internet Explorer browser. In the case of subscriptions, Internet Explorer goes out on the web and checks the pages you subscribe to against old copies of those pages in its cache. When it detects a difference, it lets you know that one of your subscription pages has changed. In the case of channels, the browser has to track the many different pages that comprise the channel. It does this according to an update schedule specified by the creator of the channel. Thus, when you build a channel, you need to say which pages make up the channel and how often the channel is updated. To support these and other aspects of channel authoring, Microsoft developed the Channel Definition Format or CDF, an XML-based markup language that you can use to write channels. CDF is a good example of XML for webmasters, since they can relate to many of the elements in the CDF language and how they help to manage web content. Let us first discuss the basics of CDF and how to use CDF to set up webcasting channels. To create a webcasting channel, all you need to do is author a CDF file that specifies which of your existing HTML documents should make up the channel. You don't need to do anything special to the HTML documents themselves. The CDF file you create should end in the extension .cdf and be placed in the document root directory of your web server. Then you can set up a link to the CDF file from your main page, inviting visitors to follow the link and subscribe to your channel. When Internet Explorer processes a CDF file, it extracts all the channel-related information and sets up the channel on the channel bar. The Internet Explorer channel bar is like a remote control from which you can choose a webcasting channel. The root element in any CDF file is the channel element. Thus, all other elements in the file must occur between channel and /channel tags. The channel element takes the attributes shown here. Only the href attribute is required, and it is used to specify the URL of the top level page in the channel. If you choose to pre-cache your channel, keep in mind that your users will have to wait for every page in the channel to download. Once you have the channel element in place, there are some other elements you can use to build some descriptive information into the channel. These elements include title, abstract, and logo. Title. This attribute for a channel works much the same way as the title tag does in HTML. It provides a short, descriptive title for the channel. What you place between title and /title tags will appear in the title bar at the top of the Internet Explorer window. Thus, you should limit yourself to about 40 characters to keep your title from being truncated. Abstract. This element allows you to include a more detailed description of your content in the channel. This description appears in a pop-up box when user positions the mouse over the icon for your channel. An abstract should be somewhat longer than your title, but you should still try to keep your abstract fairly brief. A good rule of thumb for abstracts is to keep them 100 characters or less in length. Logo slash. You could use the logo slash element to place graphical logos in your channel. Logo slash takes two different attributes, href and style. Href is set equal to the URL of the image file that contains the logo. Style can take one of three values depending on which type of logo you want to place. Setting style equals icon means you are specifying a small 16 pixels by 16 pixels logo for use on the Internet Explorer title bar. Style equals image is used to provide an image for display on the Internet Explorer channels bar. Logo images for the channel bar must measure 80 pixels wide by 32 pixels high. Finally, setting style equals image wide means you are providing an image that will serve as a link to the channel's main page. This type of image has to measure 194 pixels wide by 32 pixels high. You are not limited to having just one logo slash element. In fact, you are encouraged to include one logo of each type in your channel. Using the tags you've learned so far, you could begin to set up the channel shown here. With the basic structure of the channel in place, you're now ready to learn how to make individual documents part of the channel. You accomplish this using the item element. Item takes the same attributes as the channel element except for the base attribute. The attributes have the same meaning for each element. Thus, a basic item element might look like this. You can create titles, abstracts, and logos for an item by using title, abstract, and logo slash elements between the item and slash item tags that define the item. In each case, these elements have the same meaning as they did when used as children of the channel element. Updating your channel code to include some items, your CDF file might look like this. This channel contains two items, an XML overview page and a page on XML linking. Now that you have content placed in your channel, you're ready for the final step, setting up a schedule for content updates. You do this by using the schedule element. You set up a schedule for the entire channel by placing the schedule element immediately after the channel element and before any item elements. Alternatively, you can create schedules for each individual item by placing the schedule element between the item and /item tags that define the item. An item-specific schedule will override the schedule specified for the channel. The schedule element takes three attributes. The start date attribute indicates the date when the update schedule should take effect, and stop date attribute says when the schedule should terminate. Both start date and stop date need to be specified in the form YYYY-MM-DD. Schedule also takes the time zone attribute, which specifies the time difference between local time and universal time coordinated, or UTC. This allows people around the world to have their browsers sync up with the update time on your server. You give the specifics of the update schedule by using three different elements between the schedule and /schedule tags. The interval time element indicates the time interval between updates. The earliest time /element specifies the earliest time that the update can occur, and the latest time /element specifies the latest time the update can occur. Each of these elements takes the day, hour, and minute attributes. So, you can specify update times right down to the minute if you want. Day can take values of 1 through 7, hour can take values between 1 and 23, and minute can take on values between 1 and 59. Suppose you wanted to start your update schedule on Saturday, December 30th, 2000, and you plan on making weekly updates every Thursday morning at 9 a.m. until Saturday, January 27th, 2001. You can express this in a CDF schedule as shown here. This schedule takes effect on December 30th, 2000 and expires on January 27th, 2001. The update is to occur after 7 days, once a week, not earlier than 9 a.m. and not later than 9:10 a.m. Multimedia components make compelling additions to web pages, but variable download times have made it difficult for content developers to create multimedia presentations that are well orchestrated enough to be effective. For example, text and smaller images may load quickly, whereas larger images, audio clips and video clips usually require much longer download times. Streaming audio and video have helped to alleviate some of this problem, but they have not solved it completely. Multimedia content developers typically want presentation control right down to the last pixel on the browser screen and to the last second of the display time. Prior to now, there has been nothing to give developers that kind of control. In response to this requirement, a working group of the W3C developed the Synchronized Multimedia Integration Language, or SMIL. SMIL is an XML-based markup language that multimedia developers can use to script an entire presentation, including where each element should appear, when it should appear, and how long it should stay there. A SMIL document is similar to an HTML document in that it has a head and a body that are defined by the head and body elements respectively. Thus, you would begin any SMIL document as shown here. Probably the most important thing you can do in the head of the SMIL document is to establish the layout parameters for your presentation. This activity is similar to breaking up a browser screen into frames so that you can present different HTML documents in each frame. With SMIL, you set up the presentation area using the layout element. Inside the layout element, you can use the root-layout/element to set up a background layout upon which your other layout regions will sit. Root-layout/ takes height and width attributes that allow you to specify the dimensions of the background layout. Additionally, root-layout/ takes the background-color attribute, enabling you to specify a background color for your presentation. You can also use the title attribute to give the presentation a title and the ID attribute to give the root-layout/ a unique identifier. The region/element also takes the background color, ID, height and width attributes plus several others. These are listed here. Fit. This attribute lets you tell the display device how to deal with a conflict between the width and height given in the region/element and the actual width and height of the multimedia component. Fit can be set to one of the values listed here. Left specifies the distance from the left edge of the display that the region should begin. The default value is 0. Top specifies the distance from the top edge of the display that the region should begin. The default value is 0. Z-index specifies the region's position in the presentation's stacking order. By default, all regions have a Z-index of 0. Higher values instruct the display device to layer those regions on top of those with lower Z-index values. Suppose you had a multimedia presentation that involved some text, an image and a real video file. Then you could set up regions for each as shown here. Once your layout is established, you are ready to place the multimedia components themselves into the presentation. This is done in the body element of the SMIL document. The primary elements used for placing content are shown here. Each of these elements takes several different attributes, but the three most important are indicated here. While it is not formally required, the W3C strongly encourages regular use of the title attribute. This way, if the transfer of the SRC file fails, the display device can still provide the title of what was supposed to appear. If you have a layout defined, another important attribute of the multimedia component element is region, which is set equal to the ID value of the layout region you want the component placed in. You have the option of presenting your multimedia components in parallel, that is simultaneously, or in a prescribed sequence. To present the components in parallel, you would place their respective SMIL elements inside a PAR element. Thus, to present your text item, image and video clip in parallel, you would use the code shown here. Similarly, when presenting components in a sequence, you would place their elements inside a SEQ element. When using SEQ, a given component is presented only after the component before it has finished. The same presentation done in sequence would be scripted by the code shown here. The SMIL recommendation supports other useful multimedia orchestration features like delayed display of a component, freezing of the final frame of an animation, and the embedding of hyperlinks in a SMIL document. As soon as there is enough display and authoring software to support SMIL, you will very likely see it become the language of choice for authoring multimedia content. In fact, SMIL is already being supported in a number of software packages. The Allaire Corporation intends to support SMIL authoring in the next release of its home site authoring tool. And Real Networks Real Player G2 is currently able to pass and display a SMIL presentation. Publishing mathematical content is challenging in any medium because of the highly symbolic nature of the content. Mathematics draws on superscripts, subscripts, Greek letters, and other specialized notation to communicate its fundamental concept. Initially, attempts to publish mathematical content to the web were extremely frustrating because of character set limitations. Indeed, many early web authors were forced to resort to using images to display mathematical content. This situation was highly undesirable because the mathematical content was essentially eliminated from the document and relegated to a binary display format in the image file. Thus, it would be impossible for another program to extract any mathematical meaning from the document. In an effort to standardize the publication of mathematical content on the web in a way that still allows meaningful markup, the W3C has proposed the Mathematical Markup Language, or MathML. MathML is an XML-based language that allows you to mark up mathematical content so that viewers and other processing programs can work with it. MathML makes allowances for two broad classes of processing programs. The first class includes presentation programs that will parse the MathML code for the purpose of displaying mathematical expressions. The second class includes computational programs that will perform mathematical manipulations based on the content. MathML caters to both kinds of programs by having presentation markup elements and content markup elements. To see how these work, consider the quadratic equation shown here. Using the MathML presentation elements, the equation would be coded like this. There are several types of elements that go into the markup code. The first are grouping elements like mRow and mSub that are used to treat a set of child elements as a group. For example, the outermost mRow element serves as a container for the entire equation, whereas the innermost mRow element serves to group the 2x term in the equation. mSub is used to indicate the use of a superscript. MathML has a number of other such grouping elements, including mSub for subscripts and mFrac for fractions. The second type of element in the presentational representation of the equation is the MO element used to specify some kind of operator. For the equation above, MO is used to indicate multiplication through the ampersand invisible times semicolon entity, addition through the plus sign, and equality through the equal sign. The final type of elements used are for numbers, mn, and variables, mi. The I stands for indicators. In the code, the coefficients and powers of x are stored in these elements. All three kinds of elements provide the information a rendering device would need to correctly process and present the equation. In addition to visual browsers, the W3C expects MathML to be processed by speech synthesizers and special printing devices. This makes the grouping of elements especially important because they describe how adjacent elements are related mathematically. If you were marking up the sample equation with content markup elements, it would look quite different. The RELN element is used to indicate that you are specifying some kind of relation, equality, less than, greater than, etc. The empty EQ/ element says that you are setting up an equation. Next, the apply element is used to specify the application of some kind of operation. The operation is given in the empty element immediately following an apply element. +/, /, and // in this example. Finally, numbers and indicators are contained by CN and CI elements respectively. If content element code very likely strikes you as more complicated than the presentation element version, keep in mind that the audience for this kind of code is a program designed to mathematically manipulate the equation. For example, a user might be using a computer algebra system to solve equations. Such a program would have a much easier time identifying the equation as a quadratic equation, extracting the coefficients of the equation, and applying the quadratic formula to solve it if it were marked up with content elements. In addition to the presentation and content elements, there is also a special math element which is called an interface element. Math acts as the root element for all MathML markup and can be used to pass parameters to processing programs that indicate how the program should work with the code. If you've done any HTML coding that involves meta tags, you have experience with document metadata. Metadata is information about the document rather than information in the document. Metadata is rarely seen by users. It is typically specified for other types of processing programs. For example, a meta tag that provides a list of keywords within a document is really intended for a search engine and not for an end user. The Resources Descriptions Framework, or RDF, is a markup language developed by the W3C that enables you to mark up metadata in a format that is meaningful to programs that process web documents. By providing metadata in a standard way, it will become possible for applications to share metadata easily. As of this writing, RDF was in its final draft and seeking feedback for finalization of the proposed standard. In spite of RDF being in flux, it is still possible to look at a simple example. Suppose you wanted to indicate the author of an HTML document using RDF. Then you might use code like this. RDF is the root element and contains all other RDF related elements. The top level description element says what is being described. In this case, the web page at http://www.myserver.com/welcome.html. Inside of that description element, the creator element contains information about the creator of the page. This information includes a mention of the creator's home page, http://www.myserver.com/sarah.html, her name and her email address, all enclosed in an appropriate RDF element. This simple example conveys the essence of RDF. It specifies predicate relationships and properties of related objects. Once RDF is finalized, it will be possible to specify more complicated relationships between a page and entities related to the page, and to say what the properties of those entities are.